Hello SSG followers and YouTube followers. So this is my 14 charging procedure. Let me show you before I start my system. I show you my measurement equipment. Here we see the resting voltage of my charging battery. This charging battery is about 5 amp hour battery. So voltage, resting voltage 1197 milliamps, currently 00 as it should be. So this is the side of my primary battery, same battery, 12 volt 5 amp hour battery, voltage level 12.73. It means I charged this battery with the conventional means. So this is not an over unity system, this is just a very interesting way to charge the battery. And I start my system. You hear this noise. This is a self-oscillation noise, and you see clearly a battery charging, but this is not the way which I want to run my system, because it is too high current for running this system in this self-oscillation mode state. So I disconnect one of the connections from my SSG circuit to the battery, and then just reconnect, and I start my system at this level. So I spin the wheel, and it will take some time. I will just capture and tell you what you are actually seeing on your screen. A little bit excited and overwhelmed from the recent days, but anyway, you see the voltage of my charging battery. It immediately increased to 12.03. So it means resting voltage was at pretty high level, but the battery is not completely charged. You see 14 milliamps which currently going to the battery, but I claim that I charge my battery not by this small current. I charge my battery with a high radiant type impulses, and maybe I will capture my oscilloscope with the radiant spikes on the beta camera, on this camera. So you clearly see here on this side the battery is charging, and let's look to another side, where my primary side, 12.64 at my primary battery, and currently I am running my system at 30 milliamps. So at some point, when the spinning of the wheel stabilize, I will probably run my system at the lower current consumption. Sorry guys. But you see clearly I spent some energy, like 13 milliamps or 29 milliamps, and you see that the voltage is pretty stable at the primary battery. This is good. But anyway, back to the original, back to the where the battery hooked up, and you clearly see that this a little bit short. So I should mention, when you charge your battery with this type of the energy radiant spikes, the voltage of the battery and capacity of the battery can increase, but the capacity of the battery is increasing not fast. It's increasing slower, so it's slow process to charge your battery, but at the end of the day it's very powerful and very very good quality charging process. So what I'm hearing from the forums, yes, the voltage is not a sign for the fully charged battery. This is the reason why I didn't show you yet my discharge procedure, because I don't get the fully discharge of my battery in 20 hours. I measured my 7-hour discharge until the voltage of the charging battery dropped to 11 some volts. So the real load of the battery will be tested, and I conclude the best result which I got from my discharge procedure. In discharge procedure I do to know how much exactly I got amps from my battery. So reason behind what I'm actually showing you this video is simple: to give you a quick overview how the battery can behave when the battery charged by the radiant spikes which I produce in my circuit. So do not take this charging process as a last word, last opinion. But anyway, you see clearly, currently I can show you my side of the primary. So you clearly, the current dropped to 27 milliamps. Voltage has not increased, so the battery is good. The primary battery is very good charged. And I should mention that my charging process of my primary battery is following. I always use conventional charging device to charge my primary battery, and the primary battery is in very good shape. This is actually new batteries which I use in my current charging procedure and discharging procedure. But I want to tell you that I'm pretty happy with the result, because at the end of the day my other battery is charged by the BDE. It's not completely charged to the full capacity, but I think it has something to do with the chemistry of the battery and how chemistry is able to actually run the charging process in the actually the charging chemical process. Because when I put ions to this battery, I push the ions in the plates of the battery, and when the ion movement happened, then it means the battery charging. So it's not a fast process, it's rather slow process, but actually with the best results which you can get to the onto your battery. And it depends on the rate of the impulses, amount of not on the rate, I mean on the amount of impulses which you get onto your system. So in my case it's like 14-13 radiant spikes which are going to the battery, and you see clearly that the battery is charging. And on the other side I have this amount of energy, 26-28 milliamps. But you probably interested more to put the load on the battery. Well, I'm actually putting the load when the battery is fully charged, so it doesn't make any sense to put a load to the battery when it's charging. So do not do this. Or maybe if you do this, but you should know how much load can handle your battery. What I actually can show you, I can actually disconnect the circuit. You clearly see this protection. This is a LED lamp with a 230 volts, which are actually protecting the system from breaking out. And yeah, you see the voltage dropping at the battery. I will show you this a little bit a little bit. This is like guidance, how actually battery behaves when it's not charged by this radiant spikes. And then I put once again back to the charge. I connect again the charging cable from my SSD circuit. Okay. So battery is charging by the beginning, voltage increase happens, but of course I agree with people, to know the capacity of the battery I need to put a load, and the load shouldn't be too high because it can then damage the battery. I put actually 250 milliamps on the 12 volt 5 amp hour battery, and I actually know for fact that from one of my charging procedures I got at 1.7 hour discharge. It was like 1 hour 1.5 amps, real amps. But anyway, the goal which I have with this research is to actually charge my charging battery to stable 12 volt 66 or even higher, and then discharge the battery and get the result where I have more than 20 hour continuous work. It means like I get real amps and real work from the battery. But what I can actually say to you, from my previous charging procedures, my efficiency wasn't so high, so that I can claim 20 hour discharge rate. But what I actually can claim, I can claim 7 hour discharge rate, and 7 hour discharge rate at 250 milliamps load. It's pretty overwhelming for me, because I know that normally you cannot charge very well with impulses. And look at my costs. I mean, I'm actually using only 27 milliamps to run the system, so it's not a 1 amp to run a system. It's even less. So it's good to know that you can run the system without using high current and actually get some results. But you clearly see the battery is charging. Currently it's showing right now 12.08, and I can say only this is a good result, because when you think about resting voltage, each time when I discharge the battery, my resting voltage has increased. And the second part of the reason why it's increasing, because I use some discharging device, and this discharging device has a protection for the battery. So now I am currently using the proper procedure to discharge the battery. Once again, I'm not a big fan of the capacitor. I'm actually thinking you're losing some amount of energy when you use capacitor, because capacitor have discharge time even higher than the battery, and this is not where I'm actually going with my project. So I'm currently not interested in using capacitors in any way. I'm just interested to charge my battery, actually this battery, to charge this battery to full capacity, and just get notice how long it takes to discharge the battery, and then I can calculate the amount of work which the battery produced. So you see stable voltage increase 12.09 with a 13-14 milliamps current use. I mean, this current which you actually see, this is the amount of current which I get to charge the battery in the conventional way, but clearly it's obvious I'm charging the battery by using not the small current. I'm actually using radiant type impulses to charge this battery. So on this side, at this side you see voltage decrease, it's as it should be, and 26 milliamps to run the system. So guess I'm pretty good at my discharge rate with my primary battery, and this is actually how it should be. So anyway, I'll just give you a quick, maybe not so quick, but for the people who are actually doing the charging process for the first time, I got this result only when I done at least 12 charging and discharging procedures. If you not discharge your battery, probably you won't get such a result which I got. So it's important after each charging procedure to discharge the battery to maximum 11 volts, to not discharge your battery to lowest level. It's damaging the battery. But if you charge your battery right and discharge the battery right too, then you probably can get even better results than I. But I'm actually showing you that it's possible to charge the battery with a radiant type impulses, and once again I can clearly show you this is happening. I just disconnect one of the leads of the battery like this, and you see immediately how the voltage decreasing. This is actually normal behavior of the battery when it's under the charge. Okay, and you see in the sound which you are hearing